Today we're going to take a look at a way of writing very large or very small numbers so that they're a bit easier to work with. We call this method scientific notation. We call it scientific notation because it's often used in the sciences. Picture we're measuring the distance across the galaxy. Well, that's a very large number, pretty unmanageable to work with. But if we write it in scientific notation, it's a little bit easier. Or how about if we're measuring the size of a microscopic cell? Well, that's a tiny number, but we can make it a little easier to work with. So what exactly is scientific notation? Well, scientific notation has two pieces. The first part is a decimal, and the number to the left of the decimal point must be between 1 and 9. 1, 2, 3, 4, 5, 6, 7, 8, or 9. Notice at the bottom here, the number in front of the decimal point is a 3. The second part is a power of 10. 10 raised to some power. In this example, we have 10 to the 30th. 3.24 times 10 to the 30th is an example of a number written in scientific notation. Well, that's great, you say, but how do I write a number in scientific notation? Well, let's take a look at our first example in Part A. We have the number 93 million. We want to write it using scientific notation, and we know that there must be a single digit to the left of the decimal point that's between 1 and 9. That means I'm going to move my decimal point between the 9 and the 3, so I have 9.3. Now I need a power of 10. Well, I count how many decimal places I moved my decimal point. It moved a total of 7 places, so that means I have 9.3 times 10 to the 7. Well, that doesn't even look like the original number. That might be what you're thinking. Well, let's take a look why that is. Every time we multiply a number by 10, the decimal point moves one place to the right. If I take 9.3 times 10, I get 93. You can go ahead and try this in your calculator if you'd like. 9.3 times 10 two times gives me 930. Multiply 9.3 times 10 three times, you get 9,300. And you get the idea. By the time you've multiplied 9.3 by 10 7 times, you have the number 93 million. Example B is for you to try. It's the number 530,000. See if you can write this number using scientific notation using example A as your guide. Please pause the video here. Let's take a look and see how you did. We move the decimal point to the left. We have 5.3 times 10 to the 5th. We put the decimal point right after the 5, so we have a single digit from 1 to 9 on the left. And because we moved the decimal point 5 places, we have times 10 to the 5th. But what about really tiny numbers? Take a look at example D. We have 0.0000935. Well, we really follow the same process. We want a decimal between 1 and 9. And so I'll put my decimal point so I have 9.35. Now, what is the power of 10? Well, because it's a tiny number, it's 10 to the negative 5. Wait a minute, you're thinking, to the negative 5? What does that mean? Well, let's take a look. Remember, when we have something to a negative power, it means it goes in the denominator. So 9.35 times 10 to the negative 1 is really the same as 9.35 times 1 over 10, or divided by 10. Every time we divide 9.35 by 10, well, the decimal point moves one place to the left. And by the time I get to the negative 5th power, I have 0.0000935. That's the original number. Some people like to think of this, if it's a tiny number, negative exponent. If it's a huge number, positive exponent. Example C is for you to try. Please pause the video here. In example C, we'll move the decimal point so it's right after the 3. That's 3.67, and because we moved it 3 places, it's 10 to the negative 3rd. Negative 3rd, well, it's a tiny number, negative exponent. Example 2 asks you to write the number in scientific notation and tell them what the number is, that is the exponent. In other words, 203 million is 2.03 times 10 to the 8. Because the exponent is 8, n is 8. n is the exponent. Please pause the video here to try examples C, D, and B. Write each number using scientific notation and list the exponent. Example B, we have 1.02 times 10 to the negative 3, so n equals negative 3. Example C, we have 56,005.6 times 10 to the 7, so n is 7. D, 5.877 times 10 to the negative 1, so n is negative 1. Take a look at example 3. This is a great question. Is the number 12.38 times 10 to the second written in scientific notation? And then explain why or why not. Well, what do you think? Is this number written in scientific notation? Sometimes we might be tempted to say yes, but it really isn't. Look at the number to the left of the decimal point. It's the number 12. The number on the left of the decimal point has to be between 1 and 9. We have to move that decimal point one place over. So we have 1.238 times 10 to the third. Example 4 gives you a number written in scientific notation, 6.39 times 10 to the 7th. They want to know if you would move the decimal point to the left or to the right, and why that is. Please pause the video here, determine whether you'll move the decimal point to the left or to the right, and explain why that is. Then come on back, we'll see how you did. In this example, we'd move the decimal point to the right. When we multiply by 10 to the 7th, we're multiplying the number by 10 7 times. And when we multiply by 10, the decimal point moves to the right. Finally, we have the number 51.24 times 10 to the third. Please write this number in scientific notation, pause the video here, and then come on back when you're finished. To write this number in scientific notation, we have to move the decimal point one place to the left. That gives us 5.124. Because I moved it to the left, I add 1 to my exponent. It's 10 to the 4th power. So what do you need to know about scientific notation? Well, scientific notation is a way of writing very large or very small numbers so that they're easier to work with. When you write a number using scientific notation, you'll have a decimal times 10 to some power. The decimal, the number in front of the point, must be from 1 to 9. This is everything you need to know about writing numbers using scientific notation.